Hello everyone, welcome to my YouTube channel, Learning Computer Aided Design within Pima. So let's begin straight away. Today we're having an introduction, a basic introduction to Ansys for beginners. So if you're a beginner right there and you've installed your Ansys on your laptop, I'm going to show you how to start off using Ansys. So when you open up Ansys, this is what you'll have. Ansys has a lot of things that can be done with this software. It can do analysis, it can do modeling, thermal analysis, magnetism, a lot of things. So when this icon opens up, you can see up here we have this icon for file, for opening, new files, view, we have tools, we have units you can change, you can see the different units depending on what you want for your project, extensions, the jobs, you want to monitor the number of jobs you've been doing according to different names, and the relationship between the rest, and we can have the help icon to help you install. So always I advise people when you're beginning any project, as you can see it shows a project. If you're beginning any project, the first thing is to save. Whenever you save your work, you're safe. You save your project. So you can come, there's save project, but as you can see, mine's already saved. So first save. So when you finish saving your project, put it where you want to put it, then you can begin on your project. What a project means, you can be working, let's say you're analyzing an engine. An engine has a lot of features. It has pistons, cylinder heads, a lot of things. So if you're going to model each, you can do every component of it in a single project. Okay, you can see Ansys has analysis systems. It has many different analysis mechanisms that we are having here. There is again buckling. You can see some of them: fluid flow, fluid mechanics. We have the electric for circuits, simple harmonic. We have hydrodynamic. We have magnetism, macrostatics. We have structural analysis. So you can analyze plenty of things. You have thermal analysis in Ansys. So today I'm going to teach you how to start off. Now, the first thing I'm going to teach you about system components or component systems. Now, these are subsystems, as you can see: SCP, post, pre, external data, external models. They're sub components of this system. So, the first thing I'm going to show you, if I can pick any analysis, maybe I want to carry out a structural analysis, you can double click on it. When you double click on it, you can double click or drag on it. The first one I've dragged, structural analysis. So you can see it has engineering data, it has geometry, it has model, it has a setup, the solution, and your results. Then maybe let me take a transient thermal analysis. A thermal analysis, it also has, it's kind of similar to what we had here. So this is a structural analysis, this is a transient thermal analysis. Then when you come down to our component systems, these are subcomponents of the system analysis we've seen above. Now, why do we have them separate? Take an example. I'll use engineering data. When you see, the first thing here is engineering data, and when you check here, we still have engineering data. You can drag it also. Then the next thing is geometry. We still have geometry down here. You can drag geometry there. I want to show you something interesting. So engineering data, why are they separate? It means that I can, if I'm working on a big system, like as I said earlier on, if you're working on an engine, you have different parts, but you might find out that different parts are going to use the same engineering data. Are we at the same point? So it means that instead of doing the engineering data separately, I can come and use one engineering data for the rest of the components. First, let us learn how to input engineering data. So double click on engineering data. So when open engineering data, you can see we have physical properties like density, we have linear elasticity, we have a lot of them here. You can check all the material properties that you want: specific heat, porosity, viscosity, failure, yield strength, all of them, depending on the material you're dealing with. So, as you can see, structure steel is there by default. But to add a new material, just click on add new material. Then we can add a material. We can say we're dealing with aluminium. Aluminium. Press enter. So when you press enter, you can see aluminium, it has a question mark. A question mark is telling you like the properties are missing. When you click back on steel, you can see the properties come, and when you click on aluminium, no property has been input. So you can come here and put the properties that you want. To show you as an example, I can go for isotopic elasticity, and I can put in Young's modulus. I can say 20 x.9. Then Poisson's ratio can be 0.2. Enter. So when you click on aluminium, you can see the different properties. You can add in as many properties as you want. The yield strength, compressive yield strength, the tensile. You can go on putting all those things according to the material you're dealing with. So this is how we put engineering data. So after putting that, you can close it, or you can just go back to our project. So after, it is still saying a question mark because I didn't finish everything here, but it is okay, it's not the case. So if you have all the properties, you can input them there. So when you're finished with that, what next? So when you finish with that, why are these ones separate? They are separate because if I have many components and I'm going to use the same engineering data, I can just transfer the data from here to the different components. You can see you drag that. When you drag, you're sharing the engineering data. You can see I have this engineering data is shared to this. Then still, I can share the same engineering data. So if you're taking like a component like a piston and you're modeling it, after modeling it, you're going to carry out a thermal analysis. So for thermal analysis, we can have the same engineering data because it's the same component, and still for structural analysis of the stresses on the piston, we can use the same engineering data without setting it again. Still, the same thing happens for geometry. Geometry, you can still, after drawing the geometry, if you want to carry out different tests, let's say in geometry, I've drawn my piston, as I've said, and I want to carry out a thermal analysis to see the heat transfer within the piston, and I also want to see the stress within the piston. After having my geometry, I can still share it. So when I share it, I'll have something like that. Still, I can share the same geometry to the structural analysis. So that's how we transfer data without redoing it again under the same project. Hope you've learned something. We meet in our next lecture. Today, we're just having a brief introduction, and we've seen how to set data. So next time, we shall look at geometry. Thank you for watching. Please subscribe. Ciao.